Hi, my name is Julio Diarte. I'm a PhD candidate in architecture at Penn State University. I'm going to share with you a project that is part of my doctoral dissertation. The title of the project is Building from Waste Cardboard, a grammar for the design and fabrication of a customized modular house with waste cardboard and wood frame panels. Why am I interested in using cardboard as a building material? First of all, urban waste is a serious consequence of the human activity, and there is a global interest that includes us architects, designers, engineers on finding ways of reducing, reusing, and recycling waste materials. Corrugated cardboard is one of the least valued products, and it is highly underutilized in developed countries, where at the same time there is a growing need for housing alternatives. There is also an increasing number of research since the 1940s about the use of cardboard in architecture in different structural systems because of the advantages of the material. It is highly recyclable, it is light, and it is low cost. So why not thinking or rethinking reusing waste cardboard as a resource for architecture? To give you an idea of the structure of the research where this project is part of, I'm showing here the different stages of the research where the goal is to develop a workflow from the collection to the fabrication of building components with waste cardboard. The stage number 3 consists on an exploratory work developing craft-based and computational-based methods and tools to help users design building parts with this material, and the project is part of this stage, the number 3. The goals of the project presented in this paper are the following. First is to formalize a design system that includes the spatial and structural components of a house that can be customized and built by modules. This will be the design grammar. Second is to develop a fabrication system that generates the instructions needed to produce the building parts. In this case, wall panels made of wood parts and cardboard components. This will be the fabrication grammar. The contextual inputs are based in local housing typologies. In this case, the sausage house typology, that is a traditional urban house typology in Asunción, with a layout characterized by a succession of rooms along a corridor facing an interior patio. The second input is the social housing regulations that establish the parameters of the layout of the house. This is the structure of the grammar. In the first level, we have the rules for designing the layout of the house and the walls elevation. The second level is for designing the cardboard components. The third level is for fabricating the cardboard components. Then we have the design of the wood components, and finally the instructions for building these construction components. This paper presents the shape grammars for the first and the third levels of the structure. The first stage of the design grammar address the structural and spatial grid layout of the house using the minimum interior space dimensions set by the local housing authorities. The rules at the top address the placement of the first room in the property, and the rules at the bottom deal with the extension, modification, and adjustment of the grid. The next stage defines the functions of each interior space of the house. We have living rooms, we have dining areas, we have bedrooms, and we have service areas. Next, it's about placing the reinforcements in the structures, defining the thickness of the walls, and placing the doors on each room. The grammar also allows the user to adjust the walls, define the subdivisions of each segment of walls, and place windows. This is the preview of the derivation of the rules for designing a house, a two-bedroom house. We can see the structural and spatial grid definition, the assignment of functions, and the placement of some of the building components. Once we have defined the layout of the house, we can start drafting the elevations of each one of the walls. These are the rules for drafting each one of the components: columns, doors, windows, and wall panels. The main component of the structural system of the house are the wall panels. The wall panels are defined by a wood frame and an infill made of cardboard panels. These are the rules for designing the frame and getting the dimensions of the cardboard components. Once we have the dimensions of each one of the cardboard panels, we can start working on the subdivision of these elements. Each cardboard panel is made of different triangular section cardboard tubes. These are the rules that define each one of these tubes. The wall panel, which is the main component of the structure of the house, it's formed by a plywood frame, cardboard infill, exterior facings, interior facings. The cardboard panel is made of different folded tubes, and to make these folded tubes we use a parametric design tool that defines the scoring and folding patterns. The next level in the system is the fabrication grammar, and here we can see the rules designed for fabricating the cardboard panels. These rules are intended to fold cardboard to form these triangular shaped tubes or other shapes as well. This is a trapezoid, and here on the right we can see an example of the derivation of these rules that starts with a layer of cardboard that has all the templates on it for folding to obtain the tubes and then to assemble the panels. The pictures below correspond to a workshop that I did a year ago in Paraguay working with waste collectors. In that occasion, I didn't have these rules developed yet. The rules actually came after this experience, where I could identify specifically each part of the process. Here we can see them trimming the layers of cardboard. These are the cardboard panels that go inside the frames, and these are two of them inserting the cardboard panels inside the frame. Regarding future work, when talking about the design grammar, so one of the things that I'm concerned for instance, is how to control unexpected results in the design grammar. I did the example that I show you, but what if the user is not an architect, is not a designer? So how to control things that it might not work in reality? And of course, the system is not including the roofing yet, so that's something that I need to add as well. Regarding the fabrication grammar, one of the things that I need to test is how easy it is for users without formal education in construction or design to use the fabrication rules. The example that I'm showing here was the workshop that I did a year ago, where I was instructing them step by step how to apply the process. And now it will be really useful to test the feasibility of these rules with real users. To conclude this presentation, I want to highlight the goal of this research is to propose a workflow for reusing a material that is being wasted. And in this presentation, I showed how some computational design tools, in this case shape grammars, are helpful and can be used to support parts of the process for designing and for fabricating cardboard components. Thank you.